7, lesson 3. Let's go back to my OneNote here. If I can find it. There we go. Okay. So we're going to talk a lot today about bases and exponents. Something we need to remember, which is kind of like the basis for every question today. If the bases are equal, the exponents are equal. So what I mean by that, for example, if you had 2 to the power of 4, for example, and I told you that that is equal to 2 to the power of x. As soon as you have the bases being the same thing, you can actually drop the bases and you can conclude that 4 is equal to x then. So that's going to be the basis for today. We're going to get all of our powers to be the same base so that we can actually just forget about them and then just write 4 equals x. Okay, that's kind of how we get the exponent of x up top to be just a regular equation again. All right, and then vice versa. If the exponents are equal, the bases are equal. So that's kind of the opposite. So say, for example, you have 2 to the power of 4 again. But in the second one, it was your base that was unknown, okay? Again, if the exponents are equal, and I want these two sides to be equal to each other, you can just ignore the exponents and assume that 2 is equal to x then, okay? They kind of go one in hand, or hand in hand, those two laws. Okay, this is what we're gonna do to review Foundations 10. I want you to rewrite 32 as a base of 2. Now, I know that many of you might just know that 32 is 2 to the 5, or on your formula sheet on the back is a big table full of all of the powers and everything, okay? Just a little reminder of how you had to do this in Foundations 10. You had to do these guys. 32 is 16 times 2, 16 is 8 times 2, 8 is 4 times 2, and 4 is 2 times 2, and those are all prime factors, so you circle, 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 and that's how we established that 32 was 2 to the 5. We don't have to do that today, okay? You are allowed to use your common sense, you're allowed to use your calculator, you're allowed to use the back of that formula sheet to figure out that 32 is 2 to the power of 5. But do you remember that from grade 10? Those factor trees? Okay. So I want us to do the same thing here. So where it gets a little bit more complicated. I want to take 16 to the power of 4. And I want to rewrite that as a base of 2. Okay? So 2 to the power of what is equal to 16 to the power of 4? Your first instinct, and this will be wrong, your first instinct might be to figure out, well, what's 16 to the power of 4? Like rewrite 16 to the power of 4 as a big fat number. That is a huge number. So to figure out, can someone tell me, can someone actually do it? What's 16 to the power of 4? And don't write this down. Okay, so to figure out what that is as a base of 2 might be a little bit complicated because that number is giant. So we're actually not even going to go there. Anyone guess how we can do this question so easily? Write this as a base of 2, Nico? So you're going to set that equal to 2x, okay? So Nico wants to set that equal to 2x. So we want to rewrite 16 to the power of 4 as something with a base of 2. Then what do I do? Because my left side and my right side don't have the same base. They're not bases of 2. I can only drop the bases if they're the same. So what do I do? Carl? I can rewrite 16 as a base of 2. Can I not? We know that 16 is 2 to the power of 4, or you should know that, or that's on your sheet. So 16 has now been rewritten as 2 to the power of 4, but don't forget that that is still raised to another power of 4, okay? Yeah? Then your exponent laws that you learned about in grade 9, when you have an exponent neighboring another exponent, what do you do to those two guys? Oh, do we add or do we multiply? Only one right answer. Who says add? Oh.
That's add.
So my options are 2 to the 8 or 2 to the 16. When you have an exponent side by side an exponent, you multiply them. It is 2 to the power of 16. Okay? So x is 16, or our exponent is 16. So this is just your answer right here. You can just break down 16 to 2 to the power of 4, raise it to 4. You have 2 to the 16. Okay? All right. Another refresher from Foundations 10. I wrote it right here. If you recall from Foundations 10, if you had the square root of something, you were able to rewrite the square root of something as 16 to the power of 1 over 2. Similarly, if you had the cube root of something, you could rewrite that as the something to the power of 1/3. So in other words, whatever your index was became your denominator. Remember that? No? Okay, well, it was a year and a half ago, but just now you know, okay? So 16, if I want the cube root of 16, don't try to take the cube root of 16. There is no cube root of 16. So you are going to rewrite 16 or cube root of 16 as 16 to the 1 over 3 because your index is 3. Yeah? Okay. That's not a power of 2 yet. I want a base of 2. So just like we did in the previous question, I'm going to rewrite 16 as 2 to the 4. But then that 2 to the 4 is raised again to the 1/3. Now, we just established that when you have two exponents side by side, you multiply them. So this becomes 2 to the power of 4 over 3. I just did 4 times 1, and the 3 doesn't change. And just a reminder, I don't want you to do this, but I just want to remind you, if you were to put this back into a radical form, okay, the 2 is your base, that goes underneath. The denominator is your index, that goes there. Anyone remember what we do with the 4? Because we have a 4 up top now. What do we do with the 4? Huh? Yeah, there's two ways you can write it. You could do it like that, or it's like this. Both of those are the same thing. Okay, just a little reminder there. The numerator goes as a kind of a power after the fact. Okay, let's do another one like that because I want to do that with a fraction. So I have 1 over 64, 1 over 3. I want to rewrite 1 over 64 as a power of 2. Any takers? Can I write the number 1 as something with a base of 2? To the 0, you guys. Anything to the 0 is 1? Ring a bell? Okay, so that's option number 1. You can rewrite 1 as 2 to the 0. Let's explore that option. 2 to the 0 and 64, that's 2 to the 6. So you have that now. And that's to the power of 1 over 3 still. Okay, but I want this to be a single base of 2. And you will see that on your test tomorrow. I use the word, write this as a single base of 2. That's a double base of 2. How do I rewrite that using the exponent laws you learned in grade 9 to write that as just one base of 2? Yeah, Nico? Yeah, you subtract the exponents when you're dividing, so that becomes -6. 0 minus 6. Then all of that is still raised to the power of 1/3. And then you need to clean it up. You cannot stop there. Sorry, I'll scroll up. You multiply your exponents together. So -6 times 1/3 is -6 over 3. You are not done. You reduce that fraction. There you go. 2 to the -2. I don't care if the exponent's negative. You can leave it. We got our result as a single base of 2. Now, I just want to show you, there's more than one way to skin a cat. Okay, right? We've all heard me say that. which is just meaning there are multiple ways you can do this. Another option, you could have done this. You could have 1 over 64 become 64 because you can flip that fraction and make that exponent negative. As soon as you flip something, right, if you flip the base, the exponent becomes negative. So you could have done that, and that also got rid of the 1. And then you rewrite 64 just like we did, 2 to the power of 6, negative 1/3, and we're in the exact same spot as we were. So multiple ways. There's no right or wrong way. Okay? Exponent laws can look quite a bit different. All right. So those are bases of 2. Let's do the same thing now. We're going to do bases of 3. And we're going to start with a very easy one. If you see a radical, so you have a square root there, and you have a 2, don't work too hard. Cross them off, right? If you change that 81 to 81 to the power of 1/2 times 2, be my guest, but you are making your life so hard. They just cancel each other out anyway. And then all you have is 81, and I want to rewrite 81 as a power of 3. There, I'm done. 3 to the 4. Okay. Next one. Don't take the 4th root of 27. You can't. Okay? You can't 4th root 27. So what you're going to do instead is you're going to rewrite this as 27 to the power of 1 over 4. So whatever your index is becomes your denominator. Then, can we rewrite 27 as a power of 3? Absolutely. 27 is just 3 to the 3. So that 3 to the 3 is done, but it's still all raised to the 1 over 4. And now that you have exponents side by side, you multiply those guys together, and you have 3 to the 3 over 4. And last one, I threw a couple things at you. You have 2 terms, okay, or 2 powers here, and I want you to rewrite them as a single power. So I want the answer just to be 3 to the something. So let's just do one at a time. So start with your first one. You cannot square root 3, so don't even dare. That is 3 to the 1/2. Change that square root to a power, but that guy is still multiplied to 5. Or sorry, raised to the power of 5. Okay, what am I going to do in this one? Because I'm a smart person and I'm efficient. What am I going to do? Cross them off. You have the 4th root to the power of 4. They cancel each other out. Don't work too hard, okay? So if your index and your power are the same, just cross them off, and all you have is 9. But since I know I want it as a base of 3, I'll rewrite the 9 as 3 squared. But those 4s are gone. Okay, so let me clean up this first power here because I have a 1/2 multiplied to 5. So that 1/2 times 5 becomes 5 over 2. Okay, here we are. That's a double base. I want a single base. What do? What's the exponent law? When you have 2 identical bases multiplied together, what do you do with the exponents? This is where we add them, okay? You're going to add those guys. So you're going to put him to be a common denominator, right? So you're going to go times 2 times 2. So in the end, your base is still 3. On top there, it would end up being 5 plus 4. So you're going to have 9 as your numerator, and your denominator is still 2. That's a single base of 3. Done. All right, so now that we've got some of that review under our belt, we're going to actually go and start solving equations using those rules. So we only have 4 of these guys. Okay, we're going to solve it. So we're going to solve for x, and we are going to verify. Okay. In order to solve for x, when x is part of the exponent, x is in the exponent, that's the theme for today, you have to get your bases to be the same on the left and the right. So I can see on my left, my base is already 2. So I'm forced on my right to make that 128 a base of 2. Once they're both in bases of 2, you can drop the 2s and then just solve for x. Okay? So like I said, This left one already has a base of 2. I'm not going to touch him. On the right, though, can I rewrite 128 as a base of 2? So if you go to your power sheet on the back of your formula sheet, there. Yeah, if you go to the base of 2 all the way across to the exponent of 7, you get 128. So that means 2 to the power of 7 is 128. Now that your bases are the same, drop your bases, forget about them completely, and we can just rewrite this as 3x minus 5 must be equal to 7 then. Solve like you've been solving for years. Add 5 to both sides. 3x equals 12. Divide by 3x equals 4. Now, tomorrow on your test, I'm going to ask you to verify. Okay? It's like 2 or 3 free marks. Verifying is easy. You know what to do. You take your answer and you plug it into the original. That's not optional. If I see you plugging in your answer to like this, I'm not giving you any marks. You plug that into the very original before you changed anything, the typed out question. So it's 2 to the power of 3 times 4 minus 5 equals 128. And you check that that's true. This becomes 2 to the 7, right? Because 3 times 4 is 12, minus 5 is 7. And you check, yes, for sure, 128 equals 128. Okay, that's easy marks tomorrow. Let's do one with fractions. A fraction on a side. Now, it's going to be just a skill for you to be able to look at this and determine what your base is going to have to be. So look at your big fat numbers, the 8 and the 1 over 4. What do you think I'm going to choose my base to be? A 2. Because I can rewrite an 8 as a 2. I can rewrite a 4 as a 2. Yeah? I'm not going to choose my base to be 4 because I can't get 8 from 4 squared or 4 anything, right? I'm not going to choose that. I'm going to choose 2 because 2 cubed is 8, 2 squared is 4. Okay, so I'm going to rewrite 8 as a base of 2, and it's 2 cubed to be exact. And then that 3 that I just created has to be multiplied to the exponent that was already existing. Does that make sense? I created a new exponent. Now, how am I going to rewrite 1 over 4 as a base of 2? What? How much, Elijah? I can flip it, but then you got to think about it. If you flip the 4 to be on top, whatever exponent you're choosing has to be negative now because you just forced the 4 to move. And I want it to be a 2, not a 4 anyway. Taylor? Yeah. So the way we did the previous question, it's like, sorry, not 2 to the 0. Yes, 2 to the 0. Pardon me. 2 to the 0 and 2 to the 2. So you can do this on the side or you can do this in your head. 2 to the 0 over 2 to the 2, but if you subtract them, it's just 2 to the negative 2. Okay? Or you can just visualize that 4 moving up, and then the exponent would be negative 2 instead of positive 2. Okay? But that is still multiplied to the existing exponent x plus 3. Okay. So now, beautiful. Our bases are both 2s, so we forget about them. They're gone. And you rewrite your exponents as your new equation. But as I do that, I know that the exponent laws say I have to multiply those exponents up top together. So now you have to distribute. Okay? So you will have 3x plus 6 on your left equals negative 2x minus 6 on your right, because that negative 2 gets distributed in. If I add 2x to both sides, I'll get 5x on my left, and I'm going to subtract 6 to both sides. So I'm moving my x's to the left and my 6's to the right. Divide by 5, and unfortunately, we get a fraction, and we have to verify with that. I guarantee you tomorrow on your test, there is a question where I'm making you verify with the fraction. So pay attention because it gets a little bit complicated. Okay? All right. So to verify, you take your original typed out question and you replace x with negative 12 over 5. You do not divide 12 over 5 and get a decimal. Don't you dare. You will use the fraction. Equals 1 over 4. X is negative 12 over 5, and it's plus 3 on that side. Okay. So here I have to add these exponents together. I'm going to imagine that that's over 1, and I'm timesing by 5 to get common denominator. So that becomes a 10. So negative 12 plus 10 is negative 2. So this guy becomes 8 to the negative 2. And my common denominator was 5. 1 over 4. Same thing. I'm going to multiply the 3 over 1, top and bottom by 5. So that becomes a 15. Negative 12 plus 15 is positive 3. And that's also over my common denominator. Now, you might be tempted to be like, sure, yeah, that looks good. Those are the same. No, you need to show me more. I need your left side to be identical to your right side. That's not the case. So at this point here, I would suggest mimicking what you did in the equation right now. And what I mean by that is, let's get the left and right to look the same. So let's rewrite that as 2 to the 3 times negative 2 over 5. Let's rewrite this as 2 to the negative 2 times 3 to the 5. So I just, you know what I mean by I mimicked what we did on the left in the equation? I'm just doing the same thing here. Change those to 2's. We can start getting our left and right. And now there are multiple ways to do this. This is one option. So Carl, if you're about to suggest another option, sure, go for it. 2 to the negative 6 over 5 equals 2 to the negative 6 over 5. If you punch this in your calculator and say check mark, I'm not giving you full marks. Show me. Okay? You've got to show me. I was pissed off when I was marking your test, to be quite honest, with the amount of steps you guys skipped of not showing work, and you guys lost marks after marks after marks for not showing me. Many of you would have gone, for example, from here to here like that, and you got 0 out of 3. I'm not tolerating that anymore. I know your calculators can do a lot for you. Okay, it's time for you to do math yourself, please. So tomorrow on the test, I'm assigning questions like this 3 or 4 marks. Show me everything if you want full marks. Okay, you can stop here because your left and your right are identical. You can stop. You don't have to actually find me the value of that. You've proved the left equals the right. Okay? Okay, there's my little rant of the day. Next one. This one here I wrote because something common, a common error happens here. A common math error. If you have 5 times 3 to the x equals 135, that is not a 15, okay? That x belongs to the 3 and only the 3. If you change it to 15 over to the power of x, you just completely change the value of the whole question. You cannot do that. You have to get rid of the 5. That's what you got to do. We don't want to deal with that 5. That 5 is annoying. So what we're going to do instead of multiplying it to the 3, because that's against the rules, is just get rid of it. Divide it off. Okay? Because when we do that, we have 3 all by itself on the left to the x. And then now on the right, 135 divided by 5 is 27. And now we kind of can see that it's very easy to get my left and my right the same. My left is already simplified as much as possible. 27 is 3 cubed. So I made my 2 bases on the left and the right the same. And all I got to do now is set my exponents equal to each other, and there's no solving to do at all. So if you see a number in front there, divide it off. Don't multiply it in. Okay, this one is a very quick verification. You use the original question. So all I had to do was sub in the x for 3. Same thing here. That is not a 15. Okay, it is 5 times 9. Now, another thing, when you're verifying, when students are verifying, they're tempted to treat it like they're solving it. So they're dividing off the 5 and all of that. No, when you're verifying, you have no variables anymore. You're not solving for anything anymore. You just do PEDMAS. Just do straight up math. This is 5 times 27. My right side is 135. that multiplies to 135, and you're done. Don't start moving stuff around. Just simplify the left, simplify the right. Okay? Last one, and I threw a few things at you here. Okay. In order for you to start solving this equation, you need your left side just to be a single power of something. And you need your right side to be a single power of something, and they have to be the same base. So you look at those big fat numbers, 9, 27, and 81, and you need to just know that our base is going to be 3. Okay? We're going to make those all 3s. So 9 is going to become 3 squared. But then there's also the x. So I'm just going to make that 3 squared x. Okay? 27 becomes 3 cubed. But that is still multiplied to the x plus 1 that was already there. Equals 81 is 3 to the 4. And then it's still times 2x. You could have looked ahead and written 8x there. I'm fine with that. Okay, on my left side, I'm not done yet because I have a double power. You can't have a double power. So this actually becomes 3 to the 2x times 3 to the 3x plus 3. I've distributed that 3 in, and over here I have 8x. So I've just cleaned it up a little bit more. I still have a double power. So when you have the same base, right, bases are identical, you are allowed to just add one exponent to the other and rewrite it as one giant power. So my base is still 3, but I now have 2x plus 3x, which is 5x plus 3 as my new exponent. And now my left and my right are totally simplified down into single powers with the same base. This is when you're allowed to drop the base completely and just rewrite the equation as 5x plus 3 equals 8x. And then I'm going to choose to subtract 5x over here. So I get 3 equals 3x, divide by 3, x equals 1. Okay, very quickly, let's verify this. 9 to the 1 times 27 to the 1 plus 1 equals 81 to the 2. So I've just plugged x in to the original equation. You don't have to change these to 3s and stuff now. You just simplify. So it's 9 times 27 squared equals 81 squared. And you just use your calculator to make sure it's true. Okay, 9 times 27 squared. I don't have my sheet. Is the 27 squared. So 729, and that equals 6561. And yes, we got it. The left equals the right. Okay, so that's the end of chapter 3. Okay, so your test tomorrow is on all 3 lessons, the increasing stuff, the decreasing stuff, the asymptote stuff, the transformation stuff, and this stuff. Okay. Did I say 19 people wanted reviews? Was that my number, 19? Okay, I'm going to hand out the worksheets for today. It's a worksheet, and then I'm going to run up and make those copies.